So water contains impurities. So how to find out whether the water contains impurities or not? So by testing, we have two types of tests, that is biological oxygen demand and chemical oxygen demand. By testing oxygen, by knowing how much amount of oxygen is required to oxidize the organic waste and inorganic waste, we can know how much amount of the waste is present in the given wastewater sample. So name any industry. So all industry, whether it is a small scale industry or a large scale industry, all industries produce wastewater, and the waste depends upon the product, end product manufactured, and the raw material used. So depending upon the raw material used and the end product we get, so the water may contain only the organic waste, or water may contain only the inorganic waste, or water may wastewater. When I specify, when I tell water to be precise, it is wastewater. So wastewater may contain only organic waste, it may contain only inorganic waste, or it may contain both organic and inorganic waste. So as per the pollution control board, when I know, as it's an open truth, all the water which goes in the drain, it finally reaches the ocean, right? We are polluting our water bodies. So as per PCB, I mean pollution control board, when we are sending the water into pollution, I mean water sources, it should be pure, it should be purified in the industry campus itself. So how to purify? So many of you might have come across, so suddenly one fine day what will happen, in the newspaper you get so many fishes found dead on the seashore, so many fishes were dead in the lake. So why? Because before treating itself, the wastewater would be fed into the sea or be fed into the lake. So when the wastewater is fed into the lake, what happens? The oxygen present, the waste gets oxidized using the dissolved oxygen. As I've discussed earlier, so dissolved oxygen is very much essential for the aquatic life for its survival. Okay, so aquatic life survives because of the dissolved oxygen present in the water. So this waste present in the wastewater gets oxidized using the dissolved oxygen. So because of that, what will happen? The dissolved oxygen level in the water comes down. When dissolved oxygen level comes down, automatically the fishes will die. Fishes are very sensitive, isn't it? So other aquatic life will go away where oxygen level is high. So because of this, it will die and it will float near the lake shore or seashore, whatever it is. So how to find out how much amount of oxygen is required? So what pollution control board says, you're supposed to oxidize them itself in the campus. So how to oxidize the waste? For that, you're supposed to supply oxygen externally. So how much oxygen is required? You don't know. I have 1 liter of waste water. How much oxygen is required? I have 10 liters of wastewater. How much oxygen is required? To find out that, you're going to do a test called as chemical oxygen demand, or you're going to do biological oxygen demand. So what is biological oxygen demand? What is chemical oxygen demand? We'll discuss one by one. So biological oxygen demand it refers to oxygen required to oxidize, the amount of oxygen in milligrams required to oxidize only biological waste. Amount of oxygen required to oxidize only biological waste is called biological waste using microorganisms over a period of 5 days. It is called as biological oxygen demand. So this biological oxygen demand gives you only the amount of oxygen required to oxidize only biologically degradable waste or organic waste or organic impurities. Whereas COD or chemical oxygen demand, it gives you amount of oxygen required to oxidize both organic waste as well as inorganic waste. That is both biologically oxidizable and non-biologically, that is or chemically oxidizable organic and inorganic waste. By that we can oxidize both organic and inorganic waste. Okay, so this BOD takes 5 days time, whereas COD is instantaneous. So BOD is done by microorganisms, whereas COD is done using chemicals, okay, oxidizing agent. Since it is done using the chemicals, it is very fast and spontaneous, whereas BOD is slow because it is done using your microorganisms. We depend upon microorganisms. So we are going to find out BOD by testing the dissolved oxygen of the wastewater when it arrives, when the sample arrives on the first day, and dissolved oxygen of the sample of the wastewater on the fifth day. So anyhow, that the BOD is not in our syllabus. We'll just discuss how to find out COD. So definition of COD, it is amount of oxygen required in milligrams to oxidize both organic and inorganic waste present in 1 liter of wastewater using strong oxidizing agents such as K2CR2O7. Our purpose is to find out how much oxygen is required to oxidize the waste present. We cannot supply oxygen because oxygen also is supposed to buy. So how much amount of oxygen is I'm supposed to supply for 1 liter of wastewater? I cannot directly supply 1 cc or 2 cc or 1 liter oxygen, right? So I'm supposed to, because I'm also buying from someone else. So I'm supposed to find out how first I'm going to add this strong oxidizing agent, maybe KMNO4 or K2CR2O7. By that I'll find out how much amount of oxygen is required to oxidize both organic waste and inorganic waste. Then I'm going to supply accurately how much oxygen is required to oxidize this waste. So advantages of this is it is we get accurate value, and they get total organic load and inorganic load, how much amount of oxygen is required. So it is preferable to BOD as the results are reliable and it is spontaneous. We can complete it within hour or so. So in general, COD is greater than BOD because COD gives you both biodegradable and non-oxygen required for both biodegradable and non-biodegradable organic load, whereas BOD gives only oxygen required to oxidize only biodegradable organic waste. Okay, so let us see how to find out your COD. So in the laboratory, so we're going to prepare a standard FAS. So what do you mean by standard solution? So standard solution is a solution whose weight of solute and volume of solvent in which it is dissolved is known. Weight of solute and volume of solvent in which it is dissolved is known. By that you can find out or calculate exact strength. Where you can calculate exact strength of the solution is called as standard solution. Okay, we're going to prepare standard FA solution. So again, conical flask, we're going to prepare out 25 ml of wastewater. Total, we're going to add 25 ml of K2CR2O7 and 1 test tube of sulfuric acid. So sulfuric acid is the mixture of silver sulfate and mercuric sulfate. So silver sulfate acts as a catalyst in order to catalyze the aliphatic and straight chain hydrocarbons. And mercuric sulfate is added in order to prevent the silver precipitating as silver chloride. So the wastewater may contain chloride. So when you add silver sulfate, silver will react with chloride and it will form silver chloride. So our purpose of adding silver sulfate will go waste, right? Why silver sulfate is added? It's added as a catalyst. So but as soon as it finds chloride, it will form silver chloride and get precipitated. Our purpose of adding silver sulfate will go waste. Therefore, in order to prevent silver in precipitating as silver chloride, we are going to add mercurous sulfate. So when you add mercurous sulfate, what happens? Mercury goes and contacts with chloride and it will form mercury chloride, and silver will be in the form of silver sulfate itself. Okay, we're going to add indicator, a few drops of indicator. What is indicator added? Ferroin. That is 110 phenolphthalein, 110 ferrous phenolphthalein sulfate. We're going to titrate until the color of the ingredients taken in the conical flask changes from bluish green to reddish brown, sharp endpoint. So that is for sample. So why you get this endpoint? So out of 25 ml of potassium dichromate, when you add, so 10 ml will be used up for oxidizing the waste present in the wastewater. Remaining 15 ml of dichromate will be as it is. That 15 ml will react with FAS, and whatever endpoint volume of FAS is run down, that is for unreacted dichromate present in the K2CR2O7. Right. Now I'm supposed to find out the exact volume of K2CR2O7 which is used up by wastewater to oxidize the waste present in wastewater. For that, we are going to perform a blank titration. What do you mean by blank titration? So blank titration means we are going to take everything in the conical flask except the sample. So what is the sample here? Wastewater is the sample. I am going to take 25 ml of dichromate. I am going to add sulfuric acid and everything and indicator and titrate with FAS. For 25 ml of FAS, dichromate, how much FAS I get, I'm going to minus with that this sample. By that I will come to know exact volume of K2CR2O7 required to oxidize the waste present in the wastewater. So by that I'm going to calculate the COD of the sample. So volume of K2CR2O7 required for the sample is given by B minus C. where B is volume of K2Cr2O7 required for blank titration. Sorry, volume of FA is run down for blank titration. A is for sample. So COD of the sample is given by N into B minus A into 8000 divided by 25, where N is normality and B, as you know, it is blank titer value, A is sample titer value, 8000. So 8 is equivalent weight of water and 1000, because 8 into 1000 is, as you're calculating COD for 1 liter of wastewater, so it is 8 into 1000, and 25 is the volume of wastewater. We're taking 25 ml. Okay, so that is what here. So by substituting the normality of K2Cr2O7 and substituting the blank titer value and sample titer value, you can find out COD of the sample in milligrams of oxygen. This is instantaneous. This is how we're going to find out COD. Thank you.